Assalamualaikum warahmatullahi wabarakatuh. My name is Darina Tiramiti Azlan from Group 1, matrix number 88152526. Okay, today I will be presenting about spanning tree problem-based learning. Okay, for this, okay, our group got question. The first question is optimal network planning. Okay, the question is a regional planning authority plans to construct an integrated road networks connecting 9 urban zones. Construction costs vary significantly due to terrain, land acquisition, and complexity. The non-urban zones is city center, residential area, industrial zone, commercial district, transportation hub, suburban area, logistics center, educational zone, and recreational area. Okay, this is our graph that we got in the question. Okay, we are required to use both Kruskal's algorithm and Primscall algorithm. Okay, Kruskal's today I will be presenting about Kruskal's algorithm, which is an edge-based algorithm that selects edges with minimum weight globally while ensuring no cycles are formed. Okay, so the key steps is to list all edges with their weights, sort edges in ascending order of cost, select smallest edge without forming circles, repeat until v minus 1 edges is selected. Okay, the 8 edges is formed from 9 verticals. So v is 9 and minus 1, so it becomes 8. Okay, so first of all, um, we need to sort our edges from 1 we need to sort all edges in ascending order of cost. Okay, so in ascending order of cost, so we will start with 1. We need to find which um which has the minimum weight first, and we see that D to E is only have 1 cost. Okay, so we will sort it here, DE and GH, BC because it has 2, so and so on. We need to sort out in order in ascending order of costs. Okay, so so we will sort it. First we will make lines here, DE, and then we will choose G. Okay, so after we choose from D to E, we will choose G to H because it has the minimal cost 1, and then we will also we will make this line first, this line, and then this line, and then um, this line, and this line, this line, and then this line. Lastly, this line because it has the most cost. It the minimum cost, but we since we sorry, it's in order of cost from 1 to whatever number that is still that is the most minimal, but can connect all the vertices. Okay, so the Kruskal's algorithm is very easy to do. Personally, I found Kruskal's algorithm is easier to do than the PIMS algorithm because we just need to we just need to apa because we just need to draw the notes first, and then we just need to find all the minimal cost in order. So for me, it's very easy, that Prim's algorithm. Okay, so that's all from me. I will pass it to my group member, Zayan. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zayani, Discreet, nomor matrix AA251945. Okay, right now I'm going to explain about the prism algorithm approach. So prism algorithm is a vertex-based starting from a chosen vertex and expanding the tree by selecting minimum cost edges, connecting visited to unvisited vertices. Starting point. Begin at a vertex A city center and grow the tree systematically. So, the first step is select starting vertex. Choose vertex as A, and then find minimum edge. Connect to nearest university vertex. For the next step, expand tree. Add edge and vertex to MST. The last one is repeat until complete. All vertices included. Okay, right now, it is about the edge selection. Starting from vertex A, city center, edges are selected in order of minimum cost while maintaining connectivity. So city center to industrial zone is the first step. Uh, for example, A to C is 4, and then for the next step, C to B is 2, industrial to residential, and then for the next step, B to D is 2, residential to commercial, and then commercial to transport hub, D to E equal to 1, and then E to G 3, transport to logistics. Step 6 is G to H equal to 1, logistic to educational. Next step is H to I equals to 2, and educational to recreational, and the last step is C to F equal to 3, industrial to suburban. So total cost is 4 plus 2 plus 2 plus 1 plus 3 plus 1 plus 2 plus 3 equals to 18. Okay, and then this is the prism. So this is basically the prism chart that based on the question given. So this is the answer: A to E, E to B, B, D, D, E, S for the example I just explained just now. Okay, right now we are going to do the identical results. Okay, both Kruskal's and Prism algorithm produce the same minimum spanning tree with optimal construction cost. So Kruskal algorithms edge-based approach is total cost amount 18, and Prism algorithm vertex-based approach is total cost 18. So the consistency between both algorithms validates the optimal solution for the road network planning problem. So right now I'm going for the next person, Tisha.
My name is Shafinu Batrisha. I'm going to continue question 2. For question 2, it is organization hierarchy tree. An organization represents its management hierarchy using a tree diagram, where each node corresponds to a managerial position and edge represent reporting relationship. We were given this diagram. The question is, assign your own labels or name to the verticals of the tree based on the context of the given case study. You may use numbers, letter, or descriptive names as appropriate to represent each note in a clear and consistent manner throughout your word. So I put alphabets here to represent each note. Question A. Identify the root note of the tree. The root note of the tree is the root of the tree, which is the top one. Each note represents a managerial position, and each edge represents a reporting relationship between managers and subordinates. The hierarchy naturally forms a rooted tree where reporting flows downward from the top manager. So the root node is the one at the top. After we represent the node, the answer is R. For question B, state the parent and children of node X. Node X were given here. The root node is identified as the topmost node with no parents. Parents and children relationship are determined based on direct connection in the diagram. Leaf nodes are identified as nodes with no children. So, the parent of X is the parent of X is B. As the children of X is L, M, and N. It is because the top one is the root, is the parents. For question C, identify all leaf nodes in the tree. Leaf nodes in the tree. Leaf means the node that have no children, which is it stays as the last node. It's not a parent and don't have a children. So the leaf nodes looks like this. The answer is nodes A, C, L, M, E, B, G. That's all from me. Thank you. I'm going to pass to Farhana. My name is Syafina Batrisha. My matrix number is AA251094. Thank you.
Hi, my name is Nur Farhana Bedok Fazli. Matrix number AA250891. So I will continue explain from Trisha, which is question 2, tree structure analysis. So for my question is ED, which is degree of tree. For this tree structure, they have 4 degree. The maximum degree they have 4. For example is R. They have 4 nodes A, B, C, D. That means it's the degree of the tree. And the last question is D. Binary tree conversion. uh, which is this, we need to convert this tree structure to this binary tree. So on the left is children, on the right is siblings. So from this, R is the parents. So A is their is our children. So we need to go to the left, A, and B is the siblings from A. So siblings A is A, B, C, D. Okay, from this B, they have children, which is X, and X have children, three children, L and N, and yeah, they are siblings, so they need to go the right side, and N have their children, so need to go the left side, which is P. And C don't have children, and D is the sibling from C, and they have children, which is E and F, and E and F is a siblings each other, and F have children and need to go to the left, which is Q. The hierarchical structure preserved with maximum of 2 children per node. I think that's all from us. Thank you.